Let's take a look at using a grid layout manager, probably the most flexible layout manager we have in Silverlight today. I'm using a tool called XAMLpad, which originated with the Windows Presentation Foundation, but allows me to relatively quickly type XAML without having to run through a compilation process and build a whole Silverlight application. So if we want to use a grid, what we can do is walk up to our page as we have it here and just use a grid. Let's say background equals grey or something like that, and we'll just close that off, and we get a grid. We need to use an American spelling of grey, and it fills the current space available to it. Naturally we could set widths and heights and horizontal and vertical alignment on it to control that, and we've seen that in another video about margins and padding and alignment and so on. Within the grid, what we have at the moment is a single row and a single column. So if we put a button into this grid, for instance, let's say content equals click me, then we've got a button and it's in the grid, and it's in grid cell row, effectively row 0 and column 0. So if we put another button in there and we change that to click me 2, you can see now that all we can see is click me 2, and it is in fact on top of click me. And we can see that by perhaps putting a margin around click me 2, let's say a margin of 50, and you'll see now where we have click me 2 is sitting on top of click me. And so these have just gone into the same cell of the grid, which is perfectly permissible. There's nothing wrong with that. It would be unusual in this particular circumstance, but bear in mind, two people, two controls, two pieces of UI can occupy the same cell of a grid. What if we want to create some more cells? What do we do? Well, we have grid.row definitions, so we can go and specify how many rows we've got in the grid. Let me just close off that XML tag. And one of the nice things to do with these grids is to switch on a property called show grid lines for debugging purposes. And so as we come to add a row definition here, let's add the first one, let's add another one, now we have two rows, you can see that we can start to see how this grid is being laid out. Notice that things are just being equally spaced at this point, and if we go ahead and say grid.column definitions, and just go and paste that in as well, then as we add column definitions in here, 1, 2, 3, then those are also being proportionally laid out. And as we resize this UI, those grids cells resize as well, so we get this kind of dynamic UI to it. Now, just moving back here, go and take something like a button, or where I'm using a button here, you could be using any piece of UI, a media element or a rectangle or whatever you want. But let's go and take our button and put our button into a particular grid cell. So we can say grid.row equals, for instance, 1, and grid.column equals 1, and let's just say again content equals click me. And once again, that's going to fill the available space unless we set horizontal and vertical alignments and widths and heights and so on. And once again, of course, margins crop into this, so we can set a margin around it and it will do the right thing. But we're in grid 1, row 1, column 1. This up here is row 0, column 0, so these start from 0, which is an important thing to remember. We can occupy more than one row or column of the grid if we want to, so we can tell this thing that we want it to say grid.column span equals 2, for instance, and it will span into that column, and we can say grid.row span, of course, equals 2, and it will span across into that column. It can be quite useful sometimes when you want to have, for instance, a rectangle as the background of your grid, just to tell it to span all the rows and columns and get it to fill the space that way. But we'll put this button back into the middle of the grid. Now at the moment we're just letting these rows and columns work out how big they should be, and they're just equally dividing the space that they've got between them. So the rows are vertically giving themselves a third of the space, and the columns are horizontally giving themselves a third of the space. We can control that. One of the things we can do, for instance, with our row is we could set an absolute size on it. So for instance, we could say height equals, let's go for 24. It turns out to not quite be big enough. It's not far away. We could say height equals 10, and if it isn't big enough to fit the content, it doesn't matter. It's just what the grid does because you told it to make it 10, so it makes it 10. So this is absolute sizing. And notice that the other two rows are accommodating the rest of the space by dividing it equally between them. And more useful sizing really would be to say height equals auto, which is saying that I want the row to be as big as it needs to be in order to accommodate its content, which in our case is a button. And if we set the font size, for instance, on this button to be 32, that button will grow, and so the row will grow, and so the corresponding rows either side will shrink. And again, dynamically, as we size that up, you can see how those things are resizing themselves to be proportional. So we can say auto sizing again on a column. We could say width equals auto and get the same effect. And again, margins and padding come into this as well. But you can see that this thing is now proportionally sizing itself for column 1 and for row 1. And what we can also do is we can, in addition to being able to say auto sizing and absolute sizing, we have this notion of proportional sizing, which is kind of what these two rows and these two columns are doing at the moment. And we can control that as well. So what we can say is that this row here, for instance, should be sized automatically, which is what is happening at the moment. But then we might want this row to be bigger than that row in some way. So let's say, for instance, we might say that the height of this row should be twice the height of the bottom row. So we can say, just to be explicit, height equals star. So we use this star notation to say twice as big in this case, or let's say 4 times as big as that bottom row, and we can proportionally size those things again as we resize. It just works it all out and does the right thing. And of course we can do the same thing with a column. So we can say, for instance, this column should be of a width, let's say, of star, and this column should be width of, let's say, 4 star, something like that. And then we can see again we've got one column which is a quarter of the size of this other column after we have first laid out this column, because this one actually says something about sizing. And again, if we were to set this to just be 10 pixels, for instance, the other columns get resized to take the remaining space according to the ratio which they've given us, and we can go back and put it to auto again and it does the right thing. So the grid becomes a very, very useful layout control. You get this dynamic sizing. You can size things in terms of the rows and the columns. You can size them with absolute sizes. You can size them to be as big as their content dictates, and this can be very useful when you want to, for instance, animate some content to make it grow and shrink. Because if I make this button here grow and shrink, the columns and rows surrounding it will also grow and shrink, once again in proportion with their ratios that they've specified. And we've also got this, as we say, proportional sizing for these things, which we can do as well. So you get a very flexible layout with grids, and if you're building Silverlight applications, you will almost certainly see a lot of grids in your applications.